Okay, so now let's proceed with your buffers. So when we talk about buffers, so as you can see in the definitions here, there are mixtures of compounds that resist changes in pH upon additional of small quantities of acid or alkali. So basically, your buffers are your resistance when it comes to change of pH. So for example, uh, we have actually drugs. So usually your drugs or in your suspension or in your syrups, there are actually buffers present in it. So when you read the ingredients, usually there are actually the presence of your phosphates. You will have the carbonate presence. So what are the purpose of this? So the purpose of this compounds is to actually resist change of pH. So for example, ako as a paracetamol suspension, my pH would be at, let's say, 6.9. So this 6.9 is actually kind of neutral. So whenever it comes in contact with, for example, na-open ko na mismo ang paracetamol na bottle, what happens is that there are free radicals in the air, so such as your free oxygen and your hydrogen nga naga-float sa aton air. What happens is that it goes into your solution, and then of course ano to hambalta, whenever you are going to add more hydrogen, the solution becomes more acidic. So when the solution becomes acidic, it would be harmful for the patient. So usually when we talk about buffer, so for example si paracetamol ko gimutang ako da bicarbonate sa sulod. So this bicarbonate or this compound is responsible into getting those free radicals. Okay, they are capturing those protons floating around, and then it would just make the solution to remain neutral, to maintain its pH at 6.9. Okay, so usually always bear in mind that your buffer is an aqueous solution. It means that we are usually talking about water and a certain compound, and this certain compound should be a weak acid or a weak base. So nga a weak acid or weak base, because when we talk about weak acid and weak base, their ions or their atoms dissociate, or they partially dissociate into the solution. Magsiling ka partially. For example, H uh I have CH3COOH. That's acetic acid. In your CH3COOH, there are actually three hydrogen present in it. CH3COOH. The letter H in there, kung ma-dissociate na ang tanan kung nga letter H there, what happens? You are actually a strong acid. Strong acid ka kung tanan-tanan ko nga letter H, tanan-tanan ko nga protons gina-donate ko sa ako niya solution. So you are a strong acid. But you became a weak acid if sa tatlo to ga-donate lang ko isa, ga-donate lang ko duwa. I will not give it my all. Okay? So usually in your buffer, we are just using your weak acid and weak base. So what is the importance of these buffers? So usually in humans, us, your buffers are actually, of course, still the same man sa aton nga theory to sa paracetamol. So we resist change in our bodily system because if the body becomes too acidic, there's a chance that our proteins, that our structure will become denatured, or pwede ka da mapaso, pwede da nga mga blood vessels mo malik due to acidity. So usually it happens to diabetic patients or to people who are exercising. Grabe gid ka exercise sa a gym tapos wala siya mayo ka exhale ka inhale oxygen. So the acidity in our body increases, and also kung malumos ka mo nagakatabo, carbonic acid increases in your body, so you could die, you could collapse. So dapat sa aton body may certain manada nga buffer system that would help us restore our balance. So homeostasis gyapon naton ginastoryahan. So as you can see here, the pH of our tears is about 7 to 8. So if it goes down to 6 and 5, of course, mag-agi siya sa imo matama, paso-paso ka. So there will be uh, damages in your skin. So the pH of blood is approximately 7.4. So lower than that or higher than that would be quite dangerous. Okay? So now, these are the three buffer systems in our body. We have your phosphate, we have your protein, and we have your carbonic acid and bicarbonate buffer system. So, tanan-tanan ni sila, its purpose is to actually capture free radicals, the H in its own form, the oxygen, the sulfur, or the other toxin in our body are usually in free radicals, so they are the one responsible into capturing them, into balancing them out, and to let it become neutral in order for us to excrete all of these toxins. Okay? Batian nyo man na guro, you drink this one so that you can get rid of your free radicals and stuff like that. Okay? So the most important actually is your phosphate buffer system. And no, it's actually my mistake. It's actually your bicarbonate system. Carbonic bicarbonate system. It's quite wrong. Okay. So please change it into carbonic bicarbonate system. So all of them are important, but this is the one that I chose to explain because it's kind of applicable when it comes to your pharmacology someday. So in here, your carbonate are actually can be derived from the sodium bicarbonate tablet itself that we are taking, or it is actually produced in our kidney area or our specifically the proximal tubule. Okay, so this carbonate reacts to the free radicals, the addition, as you see, addition of H plus. These are actually products of your toxins, of your metabolisms. So when it increases in your body, amo to nga ba kung nag-exercise ka tudo, damo-damo ka creatinine, damo-damo ka da mga movement nga unnecessary. So usually we produce more free radicals. Our body becomes acidic. So your body can tolerate acidic environment. So what happens is that your bicarbonate produced from your kidneys are actually accepts the hydrogen proton. So these free radicals are accepted by your bicarbonate, and what happens is that it will be formed into carbonic acid. So this carbonic acid now is being metabolized by what we call carbonic anhydrase. So let me spell that for you. So it is called your carbonic anhydrase. Carbonic. Oh, sorry guys. Carbonic ANHYDRASE. Oh my god, kabudlay gid siya i-maneuver. This is carbonic anhydrase. Okay, let's go back. So this carbonic anhydrase now will be responsible into breaking down your carbonic acid that has been produced by the neutralization of your bicarbonate and hydrogen ion, and it will be metabolized into CO2 and your water. So your water will be excreted as sweat, or it would be recycled in the body. And the carbon dioxide, of course, is that is the one that we are exhaling. So now, let's go to your buffer theory again. So again, as I've said, when we talk about strong acids and bases, they dissociate completely. It means that if I have HCl plus H2O, your letter H or the proton in your HCl dissociates completely and it goes with the aqueous solution, therefore making it strong. So when we talk about weak acids, you have many presence of your hydrogen atoms. So amutang makagina CH3COOH, that would be your acetic acid. And then you have 3 H plus present in there, and then you are just dissociating 1. So if you're going to donate the 3, you are going to become strong. Okay? So same with your acid, with your bases. You become a strong base if you give up all of your hydroxyl, the OH1, and you become kind of weak when you retain some of your OH structure, or the ones that keep your compound basic. Okay? So now, let's talk about Ka, or your acid dissociation constant. When we talk about Ka, this is just actually similar on how to derive the water constant formula. Kita nyo to gina, ang water dissociation constant I mean. So, in order for you to get the Ka, you must have a reaction. Ari, kita nyo ni. The HA here is the generic generic representation of an acid plus water. Okay, so this HA here is the acid and this is the water, so it will now act as the base in the solution. So this HA, it will donate its proton to the solution and it will become a salt or a conjugate base. So why am I talking about dissociation constant? Because the products in here, which is your ginrewrite na lang na liwat gin, shortcut ang H3O into H. So as you can see, the products here, the A and your H are multiplied again over its reactant, which is your HA. So you will derive now the acid dissociation constant. So like your pH, okay, the Ka is constant is constant when it comes to representing its amount. So kung butang ta 1.5 times 10 to the whatever da siya, that Ka would be the acid acid dissociation constant. But when you put it into pKa, you're just making it simpler to write. Okay, so you're just putting negative log in order for it to be expressed easily. So parehas lang sila ni pH, actually theory. Okay, so when we talk about Ka, so if you have larger Ka actually, so since dako ang akon acid dissociation constant, it means nga mas grabe ang capacity ko to donate the H+, to lose my H+. So sa ngalan pa lang, acid dissociation constant. So the more taas ang akon Ka, the more nga ga-dissociate ang akon acid. Okay, the more that my Ka is larger, the more that I become more stronger, the more I became a stronger acid. But if I become now a pKa, so it will be in reverse form. So the larger the Ka, the stronger the acid. So the larger the pKa, the weaker the acid. Okay, so that would be it. And here, look at it. So this is an example of a buffer reaction. So this is your water and this is your ammonia. So si ammonia ta, it acts as a base in this solution. So when you act as a base, usually what happens is that you are the one accepting proton. So this species that you are going to produce is a conjugate acid. Okay. In this solution, your H2O acts as an acid and in turn it becomes a conjugate base. So every time gani nga may ara ta buffer nga reaction, ang gakatabo is you produce two species. If you are an acid, you produce a conjugate base. If you are a base, you produce a conjugate acid. Since gatransferanay lang imo nga hydrogen. And always remember that if you are an acid or if you act as an acid, anong ginahimo mo? You always donate a proton. Si H mo, this letter H, you always donate it. Okay? So since kin-donate ko siya, nag-OH na lang ko because I added it into my base nga NH3 before. So since I'm a base, anong himuon ko? I am a proton acceptor. Ako naman yung taga-accept sang proton. Therefore, I become NH4 in this solution. So these are just the example of your of your weak acids, and this is your Henderson-Hasselbalch equation. So usually your Henderson-Hasselbalch equation is the one used to relate your pH and your pKa. Again, your pH is actually to know the concentration of your hydrogen in the solution. So the more nga damo akon hydrogen sa akon nga solution, the more nga acidic ko. Si pKa naman niya, we are using this one to know the dissociation constant of your acid. So you are going to know if a certain acid is strong or weak basing on its capacity to let go of its H+. Okay? The capacity of it to donate. So kung weak acid ka again, jutay lang imo ginahatag ng H+. If you're a strong acid, gamay lang. Okay? So here, for weak acid and its salt, this is the formula. So pH is equal to pKa plus lagsa. Kasami ko na siya guys, is lagsa. So and for pH is equal to pKa plus log Bs. So S stands for salt, or this is your conjugate base, and HA stands for acid. Here, your B stands for base and your S stands for salt. Okay? So, let's go back in this formula. So, in here, usually, I am the acid, so this is the HA. Okay? And its conjugate base would be now the salt. Okay? Here, if I am the base, I am going to accept the hydrogen given to me by the acid, and now I will become a conjugate acid, and this is now the other salt. So these two species here that you are forming would be the salt form. Okay? So do not be confused if hindi ka makakita sang salt sa imo problem. The one that's being asked is actually the conjugate acid or the conjugate base. Okay? Goods. So again, pH is to know kung ano kadamo ang hydrogen sa imo nga water or sa imo solution. Si pKa naman niya kung ano kakusog ang acid mo due to its capacity to let go of the hydrogen. So now, kung pKa lang ang ginhatag sa imo, pwede mo siya magamit. But what if pKb ang ginhatag sa imo? So it's just the same with your pKw is equal to pH plus pOH. Do same lang ni siya, guys. But ang ginastoryahan ta diya is dissociation, not the concentration of your oxygen, of your hydrogen and your hydroxyl ion. So si pKb is actually equivalent to sa ato nga ginasolve kagina sa imo nga pOH. So here, pH is equal to pKw times minus pKb. So actually, basically, your pKa was just derived from this one.
So actually, your third formula for Henderson-Hasselbalch, the pH is equal to pKw minus pKb plus log base over salt. This thing is actually just derived from this formula. The pKw is equal to pKa plus your pKb. So this element here represents your pKa. So for the original Henderson-Hasselbalch formula. So in order for you to derive the pKa, you just have to write it as pKw minus pKb. So that's how we got this element to be in this third element. So usually ginagamit na siya if you're given pKb as you're given and you're not given the pKa, so that you can derive the pH of a certain solution.
But I will give you examples so that you will understand more. So here are the examples.
So for the first problem under your buffers, so using the Henderson-Hasselbalch, so before that, we're going to first derive the pKa value via your Ka value. So in the first problem, you're given with the amount of your Ka, which is your 1.75 times 10 to the negative 5. And then what you will do is your Ka will just be converted to pKa. So again, it will just be in your negative log. And then you input this amount, 10 to the negative 5. And then what happens is that you have the result of your 0.0000 0.01234 4 zeros 0.014175. Okay, so that is the pKa of this solution. Okay, for the second problem, we are actually finding for the pH of the buffer solution prepared with your 0.05 molar of your sodium borate. So your borate usually is a salt. So that would be at 0.005 m. And your HA here would be your 0.005 boric acid. That's the concentration. And the other given to us would be the pKa, which is at 9.24. So the basic thing that we should just do is to just, of course, substitute it to your Henderson-Hasselbalch. So pH plus equal to pKa plus log sa So that's just it. So pH is equal to 9.24 plus log 0.05 over 0.005 m. So it means here, since your pKa is actually at 9.74, it became quite high a number. So it means that the solution would be, we are expecting a basic solution. So let's see. So pH is equal to 9.24 plus log 0.05 over 0.005. What is the calculation? That would actually be 10.24. Okay, so the solution is basic. This is now the third problem under your buffer solution. So we are now going to solve for the molar ratio of salt over acid for a buffer system of desired pH. So in this problem, we are actually given the pH of the solution, which is at 5.76. So next, we are given the pKa of the solution also, which is 4.76. So the ones that we are actually looking would be the salt and acid ratio. So my salt and acid are still missing. So here, when you write that in your formula, you would have now your 5.76 equal to your 4.76 plus log S over A, because they are the ones who are missing. So what we are going to do is to transpose this formula in order for us to get the log S over A. So 5.76 would be minus by your 4.76 because we are transposing. So you will transfer it to the other side, therefore making it a minus. So what's left in this part would be your log S over A. So what can you do with this kind of area? So let me clear again. So for your 5.76 minus 4.76 is equal to log sa. How will you get rid of your log in order for you to get the S over A? So what we will do is to actually, if you want an easier life, just input in your calculator antilog, and then you input this two. 5.76 minus 4.76 is equal to S over A. So if you put in your calculator antilog, it means that the log on the other side has been cancelled. So what is the answer? Negative antilog of your 5.76 minus 4.76 would be 10. Okay, so therefore, the salt over acid ratio would be 10. So it is assumed that your letter A in the below would be the value of 1. So kay ratio, ang ginapangita tayo, hindi pwede nga 10 lang. So usually, ang gina-ratio tagit is 1. So if you've had a result of 100, and if you're looking for base over acid, so it would be 100 is to 1. So for now, the answer is 10. So the ratio of your salt would be 10 is to 1 to that of your acid. Okay? So if you don't want to use the antilog, what you would do is to just actually multiply the log on both sides, or you raise this one, you exponent it to a 10, so it will become 10 raised to 5.76 minus 4.76 is equal to S over A. So when you look at it like that, it would still give you a 10 ratio of S over A. So 10 salt is to 1 of your, to that of your acid. Constant siya guys ang 1. No matter kung pila imo amount, kung 45, you just ratio it to 1. Okay? So that will be it.
And this is the relationship of your pH and pKa. So I will not dig in deeper, but please memorize. So usually amo ni siya. When we talk about pH again, it's the amount of hydrogen in your solution. So the more nga damo akong hydrogen, the more nga acidic ko. So if I put it into a log form, I become smaller. So the more nga smaller akong amount as a pH, the more acidic I become. So it's same with your pKa. If ang Ka ko taas, strong ang akon acid kay naga-dissociate ang akon acid fully. But if you put me into a logarithm form, which is your pKa, what happens is that I become smaller in amount again, and then I become stronger. Okay? So the same lang na sila ni pH and pKa when it comes to the theory. But in here, always remember this one. When your pH is equal to your pKa, it means that when the concentration of your hydrogen is equal to the amount of acid dissociated in your solution, it means that your compound has been ionized. So butang ta si HCl ko plus water. So it means that my H in my Cl has been dissociated. All of my H there has been dissociated. It means nga 50% sa akon niya hydrogen, 50% sa akon Cl nag-dissociate na sa compound. So equal na siya tanan. So the rest, it's quite hard to understand, but just please memorize. Okay? And this is actually the indication of everything that we've talked about. So in here, ma-interpret na lang ta. So if your pH is actually more than your pKa, it means that you are highly basic and you have decreased. Guys, remember, kung taas ang imo pH, ano gani? Di ba? From 1 to 14, the higher the pH, the more you became more basic. Basically, mas nubo ang imo hydrogen concentration. So therefore, more than 50% ang ionized, it means that more than 50% of your, let's say, CH3COOH has ionized. So basi may duwa kaka-hydrogen nga nagbuya sa imo nga CH3COOH. Okay? When your pH is less than pKa, it means that magsiling ka pH is less. It means sa 1 to 14 din ka, ara ka sa lower, you become more acidic and you have more concentration of hydrogen inside you, and more than 50% kuno ang unionized. Magsiling ka unionized, wala nag-dissociate. Gatapikay lang sila gyapon, wala sila charge. So they did not become sodium and chloride. They did not become H and Cl. So combined lang sila gyapon. So if your pH is equal to pKa, it means that both of your compound or the compound equally dissociated. So the other one became salt, the other one become acid. They are in equilibrium. Okay? So when this happens, this is actually beneficial to drugs that are not really stable. So kung ini nga drug toxic na siya, for example, digoxin. So if a certain drug is actually toxic, so we want it to be 50% ionized, 50% unionized in order for us to just absorb the 50%. So para hindi tanan-tanan ma-absorb sa aton lawas. Remember, the unionized form or drug or compound are usually permeable sa aton cell membrane. But the ionized form are actually not taken up by our cells. But the ionized are the ones being dissolved in your water. So, siya ni ang aton nga ionized form ka dapat kung ara ka sa Chani area in order for you to be dissolved, but in order for you to cross the membrane barriers, you have to be unionized. So, this theory is important when you go to your kinetics. Okay, so for now, overview pa lang ni siya. So, amo ni hambal ko, if you are ionized, you are water soluble because you are polar. So you do not cross the lipid membrane, but you will just be solvated in the stomach and in other liquids present in your body. But if you are ionized, you will become water insoluble. You are non-polar. You are hydrophilic. So, I mean, you are going to cross the lipid membrane. And I think that's it. So here is the relationship of everything. So it's just confusing at first, but I think if you get the hang of this, you will get it. So I will just give you a detailed explanation of the calculation so that you will learn more, and just ask me for questions if you want to. Okay, so that's it.